Hey everyone. Today we'll look at how to build your very first Cosmos application from scratch. This session is aimed at people who may not be that familiar with Cosmos or even Go. So we'll look into what parts constitute a Cosmos application, how they interact with each other, and try to build something useful. So the application that we'll be building is a simple voting application. So you have a form to create your poll, then you have buttons to make your choice, and the choice is registered, and also add a feature to charge people for creating polls. For this, you will need Go installed, as well as Node.js for the front end. We'll be using Starport tool to scaffold and serve our application. So if you haven't installed it by now, please do at github.com/tendermint/starport. So let's start. I have Starport already installed. So let's begin. First of all, let's scaffold the boilerplate code for our application. We use Starport app and a path, and we'll call this application a poll. So we can see that it has generated a directory called poll for us, and let's explore what has been generated. So this is a very simple, almost empty application, which contains only a few directories. App directory contains app.go, which is the main file of our application, and it ties together all the modules we use and all permissions. We won't be looking at it right now, but it helps to know that everything ties together in this file. Then we have a CMD directory with two directories for CLI command and D command. So you would, after building your application, you would see two new binaries. In our case, poll CLI and poll D. Poll D is used to launch our node, and poll CLI is used for interacting with our application. So most of the commands that you will issue will be with poll CLI. Front end is a directory scaffolded for us by Starport, and it contains a web-based Vue client. Of course, you're not limited to Vue. You can use any framework you want, or no framework at all. But we're using Vue just for convenience. And there's a next directory which contains custom modules that you build. In our case, that's only poll, which will contain all the logic. We'll go through the files later on. So after we've scaffolded our application, let's try to run it. We run Starport serve, and it installs all dependencies, builds the application. Then it will initialize the chain, create users for us, and launch a simple welcome screen. So yeah, we can already see that Tendermint consensus engine is running, as well as the backend of our application. If you go there, we see that it's running. Also, the user interface has loaded up by now. So this user interface, what we see, is served from the front-end directory. Okay, it's pretty much empty right now because we haven't added any features. Let's do something about it. Going back to our application, we see that it has poll entity, so we need polls and we'll need votes. Let's start with polls. So using Starport, we can also generate types, data types to be precise. Type poll. The first argument is the name of the type. In our case, it's poll, and then goes a list of fields, a list of properties. So a poll will have a title. So we want our poll to be named, right? And we will have a list of options. So if we open X directory right now, we'll see that it has generated several files for us. First of all, handler. It generated a type for our poll, and it modified our client keeper. To understand how it works together, let's look at the first of all, what has been generated on the web client. So we run Starport server again to rebuild the R application. It takes a while before it compiles everything. And now we can see that it's running. So after we've scaffolded our type, we get this new form. So for each type you scaffold, you get the form. You can not use it, but it's useful to get an understanding what happens. So if, for example, we take one of the mnemonics from a user that has been generated for us and sign in, we'll see that this user has 1,000 tokens. And now we can actually create something. So say, hey, Starport. We're live. So yeah, what happened is we signed in. So we signed into our account inside our browser, and we get a public and private key to sign our messages, our transactions. And then we created a transaction that contained a message to create a poll. And then we requested a list of polls back. So if we try that again, but with inspector open, we might see it a little bit better. So let's say foo bar. Let's make the request. So we can see that several requests has been made. First, we go into our account to see how many tokens we have in case our operation costs tokens. And by the way, the request was made to localhost 8080, but in our proxy, we redirect this request to localhost 1317, our backend. So after we got our information about the account, we make requests to poll/poll, and the request is a post request. We are sending the data that we want to be included into our transaction, which is a title and options. And what we get in return is a list, a standard transaction, standard non-signed transaction that is formed the way the blockchain application expects to receive it. So the data that we have passed was formatted this way. Then what we do is we sign this transaction that we got from our backend, and we broadcast it using the /txs endpoint. After it has successfully been broadcasted, we request a list of polls by making a GET request, and we get requests back. So if we use our backend, we'll see we actually have this available for us. So obviously we can use any kind of front end to fetch this data back. Graphically, it looks something like this. So again, from the browser, we make a post request to our endpoint. It creates an unsigned transaction with messages, sends it back. Then we sign it. Then we post the signed transaction back to /txs. This transaction contains messages as well as signatures. So your backend application can verify that it's actually you who did sign this transaction.
Dennis,
then messages. Yeah.
I have a request from Mudit. He said he's unable to access the application on his A0 port. And he said there's an error when serving, and the error is in initializing the chain. And he asks you to please check /init.sh.
Okay. Let's debug this problem. If you have a problem,
same error.
Okay, that might be. Let's see. What happens if you run make init? Should I go to the channel? Where was this question asked?
It was asked privately. I can just post it here.
Okay, I think we had a similar type of question in our issues. Okay, one of the problem might be that do you have Go installed properly? Like after you scaffold your application and you go into okay, yeah, I can see it in Zoom chat right now. A message from Nick. The problem is that you don't have the application installed. So after you run make, what it does is it compiles the application that you're building, and it installs two binaries. In our case, blogd. I mean, in our case, pold and pold CLI, but in your case, it's blogd. So to verify that it installed it correctly, you run which blogd. No, actually, Git has nothing to do with it. It's just, again, I'm answering a question from Slack, from Zoom. It uses Git for versioning, but this error doesn't affect anything. So make sure that you have Go in your path. So that's one of the things that people often fail to do properly when installing Go. So you need to have Go bin inside your path. For more instructions, you would want to go to the Go website and actually read how to install it. It depends on your operating system, but Golang install. Yeah, it will tell you to export your path. So if for example, you're building a blog application, and after you type which blogd or blog CLI, it tells you like something is not found, then your application was not installed. So you need to make sure that you have Go bin inside your path. Otherwise, you won't be able to run your application. So you can also you can build your application manually with make command. And if you go into the make file, you can actually see what it does. So yeah, the answer is please make sure that you have go bin inside your path.
Okay, we'll just wait for confirmation from people who got this error to make sure that, okay, even after setting the path, make still doesn't run.
Okay, let's see what's that all about. Make doesn't run. When you run make, does it give you any errors? Like it should spit out a bunch of text, but you shouldn't see errors at the end. You can just type it in Zoom chat. I'll see it immediately. Okay.
Okay, cool.
Cool.
Modit is back on track. Okay. It was the path issue. Cool.
Yeah, we're aware of the fact that it's sometimes confusing to install Go, so we'll try to kind of include it in Starport information about how to do it properly and like catch errors before people actually encounter them, because we've seen a bunch of errors that are not actually Starport but related to Go.
Mm-hmm. Waiting to get back from Nick also. Nick, are you okay? Is everything okay for you? Okay, no, okay, add the path, but still having error. Can you pass the error here in the chat, Nick, so we can see it?
Yeah, so if you've successfully added a path, to check that everything's working, you run make, it builds the application and installs it. After this, did you source profile after adding the path? Yes, either you should, if you do it in your terminal, like you've manually added a path, go to your path, then you should source your profile, or you can do it permanently in Bash or C or any config file. So yeah, I would say you should source it. So yeah, following the instructions on Golang website, you see that they you actually can modify your .profile to be shell independent and just add this line and then source your profile or restart your shell.
We'll make sure to add all these details in the docs, just to make sure everyone is following that. Okay, we have from Nick here.
Yeah, this is the same error. So it tells us block D, no such file or directory. So it can't find the block D binary. If you run which block D, let's go install problems. Yeah, I mean, it's not related to Starport per se because it's just Go, but it still helps to, yeah, just a link to how to install Go and maybe, but yeah, I just want Nick to kind of install it. How can we help? Oh, I see the problem. Thank you. Okay, now I think we can move on.
Okay. Let us know if anything else comes along on the way, and we'll make sure to stop. Okay, back to you then. So going back to the transaction lifecycle.
So we send the post request with our data to our endpoint. We get back transactions with messages. Then we sign this transaction using the key inside our browser. Then we send back transaction to be broadcasted on using the /txs endpoint. This transaction includes messages that are handled by a thing called base app within Cosmos SDK, and it ends up in handlers. And after it is handled by handlers, you can think of it similar to if you're familiar with building web applications, they have like HTTP handlers. Well, that's something similar, but for messages. And then it's passed to a keeper, which is a part of your application that is responsible for writing the data into persistent storage. If we map this this diagram here, we would see that for the blog /post, or in our case it's poll, but we have a REST directory, and it has endpoints. So you can see that it has like get, post, endpoint methods you can use to make requests. And TX poll actually accepts the arguments that we have provided and creates a standard transaction that gets returned back to the browser. So the first step happens inside the REST directory. When it comes back to the browser, you sign it, and then you post it to /txs, which is not in our directory. And then the messages, each message, you can have many messages that get routed to different handlers. So after you've broadcasted a signed message, a signed transaction, your messages are handled by handlers, which are here. So in our case, there's a handle message create poll. So after creating a poll, we send this type of message, and it's handled, and then it's passed to a keeper. So we're calling a keeper method called create poll, which lives inside the keeper directory. And what this does is it basically writes the data into persistent storage. And you can think of persistent storage as being this one giant key value store that is ordered, and you have keys, which are strings, and you can have values, which can be anything you want. So we take a poll prefix, which is just string poll dash, and we use poll ID, which is just a unique generated ID. And we take the whole poll object and store it as a value. So in the end, you would see if it was encoded in JSON, you would see like poll, then you would see a unique number, and you would get an object which contains title, options, right now it's a string, and so on. So that's how it would be stored inside. That's how it's easy to think how it's stored inside persistent storage. Okay. Now let's go back to our application. So we've scaffolded this thing, but it doesn't really look like what we wanted to achieve in the end, right? The first difference is that we have a string for options, whereas we would like it to be a list of strings, so you could add options. So to do that, we need to make some modifications to our application. So first of all, we go inside type poll file, which describes our poll that we're creating, and we'll be replacing a string with slices. So our application will expect us to pass an array of strings from our client. Each message is created using a constructor, right? And we need to tell our constructor that we're expecting a slice of strings instead of string for options. And we need to go into our REST directory because we are building a web client. So, and we need to replace a string with slice strings as well. So 3 modifications in these files. And also, you can interact with your application not only from a web client, but also from a CLI tool. So we have, as well as a REST client, we have some files that describe behavior of your CLI client. And your CLI client the way you will interact with your application is you will use poll CLI. And you can read about how to use it using help, but it has tx subcommand, which also has a poll subcommand. And if we ask for help, we'll see that we have a create poll command. So create poll, and then we pass arguments. In our case, we pass some title and some option, but as strings. Instead of this, we want an array. Actually, let's try using it before we change. Yeah, we'll just change it right now. So inside tx poll, we have part of our application that parses command line arguments, and right now it just takes the second argument, which is in our case is an option. Let's replace it with something else. So what we want is we want a title, and then we want arg1, arg2, and each arg is an option. Like in this case, it's the name of soft drinks. So what we will do is we will actually take our arguments, and then we will take everything except the first one. Okay, so to recap, we modified our type. We modified a file that is responsible for generating messages and REST and CLI clients. Now let's rebuild our application to see whether it's working. We also use Starport Surf for that. So yeah, again, it takes a while before it does. So now let's refresh the page. Of course, the UI hasn't changed because we didn't make any modifications to our front end, but it all builds. So let's move on actually to our front end. So we use Vue, but you can also use any framework you want. And let's start our application again so that we can make live changes to our front end. Index file describes everything you see on this page. So we have a wallet. If we make changes, we'll actually see that it's updating live. And type list is just a scaffolded forms for our types that we've created using Starport. We uncomment that right now because we don't need, we'll create our own. And we will create a poll form component. It doesn't exist right now, but we'll create it. Inside our components directory, we'll create a file called poll form. And what this file will do is describe both the template and the JavaScript that we need for this to work. So this form component will have an input. So we're using a built-in component called app input. It will also, judging by the screenshot, so it will have a list of inputs for options. So let's say we have input for our options. So this will be a placeholder. This will be a title. So we're using placeholder to tell that it's a title. And this will be an input called options. We'll also have two buttons, one for creating an option and one for submitting the poll. So it's add option. And create poll. Okay, now we have two inputs. Nothing works because we haven't added any logic to this. So let's add some JavaScript. So we'll have a title and options. So let's describe it in data. Have a title, options will be an array. So this is just the data that our application uses locally. And we use vModel to tell that this input is responsible for the title. And we'll loop through an array of options to display our inputs. So v for each option in options. And we'll pass a vModel. It'll be an option title. So for each option title, this input will be responsible for option title. Now, when we add an option, we want to handle the click. We'll just say it's add. And when we submit, we also want to handle this. So now what is left to do is describe the methods that we're using, add and submit. First, add. So what add does is it takes a list of options and it spreads the existing options and it adds a new one with a title. And we have a submit method. So submit method will do several things. It will first submit our transaction, and then it will fetch back the data that we've created. So for this, we're using Vuex, and we dispatch a message called entity submit. You can read. You can look up the definition, the code inside src store index. And we'll pass a payload, which will contain our transaction.
Dennis, and then we'll comment from Jordan in the chat.
Okay.
He's discussing a comment here.
Yeah, that's a good catch. Well, we didn't add unique IDs to, so yeah, the question was, not the question, but you got to add key option to v4. That's actually not a terrible error. It will still work, but it's a good idea for each entity to have unique IDs. So you could say key option dot ID, but we don't have IDs. We could generate it, but we won't do it now. But yeah, that's a fair comment. So after submitting our entity, we will fetch back all transactions. And now we need to define the payload. So payload is just the same data that we have. So it has a body with title, this title. So it's the same title here, the same title inside our template. And a list of options. But we just need a list of strings, so we just map every item and we pull out the title. And since this is a very generic operation, we need to also pass what type it is. In our case, it's a poll. Okay, let's try it out. Options work. And if we pass, say, text editors, poll, first one, Max, VS Code, then okay, cannot read property get nonce of null. That's interesting. It's actually not very interesting because we forgot to sign in. So right now it doesn't really handle errors, but if it did, it would tell you that you probably should sign in. We use one of the passwords, one of the accounts that was created for us. And now we'll try again. And we can see that it has probably succeeded, but we have no really confirmation in our UI because we haven't coded that yet. But we see that we have sent a transaction, create poll transaction. And now if we go back to our backend, poll/poll, we would see that in fact it did create an entry for us. So instead of kind of coding the front end, I'll just copy it from my tutorial to save us some time and go through it. So what we need to do is we need to add this list of polls, basically, right? So you can vote. So we've created a poll form component. Now we need a poll list component to list them all. And let's see what it does. So it goes through the list of polls, which we pull from our backend, and it creates buttons for everyone, for every entry. And we can submit our choice, and we'll dispatch dispatch a message. So if we look back, sign in, operating systems, Linux, macOS. Yeah, we forgot to add it to our index. Yeah, now we can see that we have a UI. Except when we actually try to vote, it tells us that it can't because we haven't provided a vote type. So now we need to go back to our Go application and actually add one more type, which will be the vote. So let's again use Starport type to generate a vote type, and it will have poll ID because we need it to be connected to the poll, and it will have a value, which is just a string value of the item that you have selected. Okay. Now we can see that it added files similar to what we had before. So it handles create vote messages, and it also added type vote. Now if we use Starport to serve our application, sign in, yeah, make sure to copy it correctly, because if you don't, then it won't sign in properly. And we have frameworks. So yeah, one more thing we should probably add is we need to request, after we submit a form, we didn't do it properly because it doesn't wait for us to submit a form. It just immediately requests back the list. So we should probably wait for it. So now let's say test poll, version 1, version 2. So it takes a while before it processes. That's interesting.
Should I try doing it?
Yeah, again, I haven't signed in. Poll 1. 2.
And awesome.
Yeah, so now it's better.
Don't forget, if you think, you get the option.
Sorry, I think I'm hearing someone's talking in chat. Okay, now the only thing that's left for us to do is to make it possible to vote. Now, if we vote, the vote actually gets registered, because every time we click on a button according to our poll list component, it submits create vote. But then say we decide Ruby on Rails. Now we can see that it actually registers 2 votes for us, which is not something we want. We would like a vote to be just changed. And to fix that, we need to go back to our application and see how our application records the data that we send it. So if we go back to the keeper, remember keeper is a part of your application that is responsible for writing data to storage. And we'll see that, again, this is a large key value store. And the way we store it right now is the way we store votes is we have a vote prefix and then vote ID. So every time you click, the application actually creates a new vote. What we want to do instead is we want a different key. So every time you cast the vote, it should overwrite the existing key. So we're interested in this line, and instead of just adding vote ID, we'll add poll ID. Then we'll add a dash to differentiate between our tokens. and we'll add a creator, which contains an address. Okay, now it automatically rebuilds our application, and let's see. Okay, we refreshed the page, it cleared our state. So now, if we sign in, say languages, JS, Go, Rust. And we cast a vote for JS. And then we decide that we're interested in Go. Yeah, so it replaces the value instead of counting it twice. So that makes sure that you can't cast 2 votes. Okay, that's pretty close to what we had in mind originally, but we would like to add one more feature, and it is to charge users for creating polls. So let's see how we can do that. So one of the benefits of Cosmos SDK as a framework is that it's built on top of a blockchain, and you have certain features like tokens built in. So that's an advantage over something like Ruby on Rails or Django or any other framework. So let's use that. So what we want is we want to charge a user before the poll is created. So as you remember, messages are handled in handlers, and then they are passed to, then a create poll method is called. So we want to charge a person before create poll is issued. So to do that, we will transfer funds from the user's account, from a user's account to a module account. So each module can have a wallet, so to speak, like an account for itself, where you can store tokens. So let's say module account, and it will have an address. So we're using SDK pack address function to create an address for our module, and it will, using a crypto package to hash the name of our module. So what this does is it uses our SDK, several functions from the SDK to create a hash of our module name and then create an address for it. So now we have an account for a module. I mean the address of the account. And now we need to actually provide payment information. And let's say it costs 200 tokens. Now, if this operation succeeds, then we just proceed. And if it doesn't, we just exit with an error. So we're using CoinKeeper to send coins. Let's see what arguments it expects. Yeah, it requires a context from address to address and an amount. So we're passing a context, then from address is poll creator. We have that information inside our message. And we're sending it to our module account, and we're sending the payment. And we return nil and an error. So we've saved before So we made a mistake and we saved, and our Starport application actually stopped rebuilding because the binary the code no longer made sense. So we just need to make sure that our front end is killed as well. Okay, we might be ready right now to build our application again. Again, we're using one of the passwords provided for us. Poll test option 1, option 2. So we see that we have like 1,000 tokens right now. Create a poll, and we refresh the page, sign in. See, right now we have 800 tokens. Of course, you can modify your front end to request the information about tokens automatically, but you can see that we've 200 tokens were deducted from our account. So in production, you might approach this differently, but for demo purposes, this works. So you can see that it's pretty easy to add payments to an existing application. So overall, it looks very much like a web framework for building backend of your application. Of course, it's very different under the hood, and one of the main differences also is that you're using public key cryptography to sign messages, right? You have public and private accounts, public and private keys, and we're using a mnemonic to generate them and to sign transactions using the private key inside your browser. Okay, this is a poll application. Now, the difference between, not the difference, but the way you build your application is by modifying this poll module. And when you build and actually deploy it, it becomes not immutable, but you can't really redeploy it every day without upgrading. And the upgrade process is a bit more involved than what you might see in non-blockchain applications. So using Cosmos SDK, you can actually build a part of your application that is like constant. The features that you really want in your app, in your blockchain to have, maybe the rules of the game, so to speak. So it's a very good tool for that. But say after launch you want to extend the features of your application, and for that there's a tool that complements Cosmos SDK, and we'll talk about it. But before we do you have any questions so far?
Okay, time for questions.
Okay, well, feel free to interrupt me if you do have any questions. So we've looked at how to build an application with Cosmos SDK, and when you compile it, it becomes part of your blockchain, and you can't really change it immediately after the fact. But alongside Cosmos SDK, we can add support for smart contracts, which you can update. And it might be very useful for you to have this option to extend the feature set of your application after you've launched. Okay, I see a question in chat. Ran into another error while trying to, please check makefile. Okay, if you run into any kind of errors while building, make sure to just run make, and it will build your application. And if it can't, it will tell you what kind of errors. So you might have forgot to add a comma or misspelled a word, and you will see errors in your terminal. So just run make, and it should tell you what's wrong. And after you fix an error, also make sure that your front end is also restarted. So just kill all node processes. And one more question: why you've chosen Vue over React? Is it Vue Cosmos better combo? No, absolutely not. So for the front end, we use Vue just because it's a bit simpler than React for many people. Like it's a bit more friendly version of a JavaScript framework. Of course, that's just an opinion, but we're under the hood. We're using Cosmos JS library, so you can, if you go into store, you'll see we're importing from Cosmos JS. And of course, it works with any framework and even without a framework. And it helps you to sign transactions, create a wallet from mnemonic, and broadcast transactions. So this is just an example of how you might build your front end. You don't have to build it like that, but it might be a good starting point for people who are not familiar with JavaScript development. They need a framework to start with. And we think that Vue is a pretty good choice for that. Okay, going back. So we have an option to build our application using Cosmos SDK. And we also have an option to use smart contracts. And the difference is that with SDK, you build your application in Go, and it gets compiled to the binary that represents the node of your application. So everything is hard-coded into the binary. Whereas with smart contracts, what you do is you write your contract script, essentially, and then you upload it to the chain. So we have a transaction to upload the code. Then you instantiate it, and you can use it, and you can update it. I mean, you can create new versions of your contract. So that's a useful complementary feature of Cosmos SDK. So let's add support for smart contracts right now. We're using Cosmos WASM library, and we'll be adding it to our existing application that we're building. So again, using Starport, you type Starport add WASM. Let's first do git init and just add all files to see what has changed, or what will change after we add WASM. Starport add WASM. And you can see it modified app.go. So it imported WASM, instantiated the module, and did some bit of housekeeping, as well as modified our Pulse CLI command to import WASM specific commands. So you can use Starport add WASM for that. Alternatively, you can follow a guide adding Cosmos WASM support manually, just to see what has changed. Okay, now after we've done that, I'm just following my own tutorial so that I won't forget what needs to be done. For this section, you actually need Rust Cargo Package Manager and Docker installed. Let's run Docker right now. Docker is used to build your contract locally and optimize it to be uploaded to the chain, because if you build your contract regularly, you would have a 2 megabyte file, which is very inconvenient because every piece of every byte counts on your chain, so you wouldn't want to upload 2 megabytes to the chain. So after we've added support to our application, we can run Starport serve to make sure that everything works. Okay, we can see that it's working. Now, right here, we're using contract CLI, but in our case, it's full CLI. And let's see what commands have been added. If we just type whole CLI tx, we see that a new subcommand appeared called wasm. Let's see what it offers us. We might have a question in chat. Okay, well, let's answer this question. Would you say Starport is heading towards a framework such as Ruby on Rails or Django? No, it is not. It is using Cosmos SDK. It will be using Cosmos SDK as well as Cosmos wasm. So it's a very helpful tool, a companion tool for the SDK. The plans for Starport include much better front-end generation. So for people who are familiar with blockchain development, they would get benefit from Starport by having all the components they need to actually build their application without going deep into front-end development. And for web developers, we'll be automating, like we do right now, automating certain operations like adding support to Cosmos wasm, right? So if you had to do this manually, you would have to make sure that you don't make any mistakes here and you know actually how to do it. And adding a type is also a pretty kind of routine, but a routine operation that it takes a while to create all these files. So with Starport, we're providing value by automating things that you shouldn't be doing manually. And yeah, we have a lot of features planned for Starport, including restarting your application, initializing your application. So making it easier to use is our priority. Next question is, can you post that Notion blog post in chat, please? Yes, sure, absolutely. So we have a couple of tutorials here. I'll just paste the link in chat. We'll also be publishing them on our website at tutorials.cosmos.network when we kind of make some changes to the phrasing and dot all I's and cross all T's. Okay, going back to what we have, we see that we have a couple of new commands under our wasm subcommand. And one of them is store to upload wasm binary. And two, we won't be writing a contract right now because it's a topic on its own. And I think there already was a video about smart contracts. This is just 101 on how to get started with contracts. So we'll use an existing one by Cosmos wasm team. We'll use cargo to clone this contract. It's called a counter. It's a basic counter application where it increments an integer. and we can see that it has created a counter directory for us. Let's go into this directory. And the source code is contained inside the src directory. We have contract file, we have messages, and we have state. So developing smart contracts in Cosmos world is actually somewhat similar to the SDK because you also have messages, for example, right? Very familiar concept to Cosmos SDK developers. Like every transaction has messages and you handle them. So right now, the application is already complete. We don't need to add anything. The only thing we need to do is to build it. So we're using this command. You can actually find it in developing.md. So we'll use that to build it inside Docker. So it takes quite a while before it builds everything. Okay, interesting. Error could not compile Cosmos wasn't. Okay, let's say cargo build to check that we have our log file. Yeah, we do. I think the problem might be that they have updated already for the newest version of the SDK, and we're using version 38 and not Launchpad, but let's see if that's the case. Yeah, that's probably it. So what we can do is we can basically go into Starport, check out the development version. You would need to do that when it's released, but let's make the latest version of Starport. Actually, uninstall Starport just to install it from our develop branch. So yeah, it's rebuilding Starport. And now let's create an application specifically for our contracts. Let's call it the blog. And we'll use Starport to add Blossom. Okay, we got a question. Hey, great workshop, thanks. Can you share some good resources to get to know Cosmos and Tendermint better for a blockchain dev migrating from another platform? Some things that cover the theory and protocol nuances as well as development basics. Well, we do have very good documentation. So if you go to Docs Cosmos Network, you could actually have a very good introduction into how it all fits together. Also, Docs Tendermint, if you want to read more about the consensus engine, we have tutorials. So these tutorials that I've I've demoed today will be added here as well very soon. So yeah.
In the chat.
Another question in chat.
From Stoyan. Will it be better to have also Starport like Docker?
Better to have. Well, you can install Starport in Docker, but I don't think it adds anything if we bundled as it as an image. So yeah, right now Starport is a standalone binary, and you can run it inside Docker if that's your thing. But yeah, I mean it's useful. Maybe we should provide an image with Go already installed, where you can and Starport already installed. I don't think that will be like the main way of using Starport. Similar to how if you're coming from web development, you have like Vue Create or React Create app. You don't bundle them inside Docker containers, but that's something you can do, definitely.
I think he asks more about like the form, the form of the code to be similar with the other steps as well. Like Docker run and Starport and Cosmos.
Yeah, again, it's bundled. It's distributed as a standalone binary, and I don't think it really makes sense to package it as an image. But is IBC Relayer set up in the roadmap? Yes, definitely. We are looking forward to IBC and modifying Starport default templates to take IBC into account. So right now you can think of Starport as a general purpose companion tool for Cosmos. So yeah, we will be probably scaffolding relayers, or at least taking IBC into account for the application that you scaffold with Starport. Okay, let's try again and use Starport add wasm. It should be rebuilding our application. Okay, we've run that twice. We've added Starport. We've added wasm twice. Let's retry that. Now let's download the application again and try rebuilding it. So we first build without Docker, just to generate cargo log file. Again, Rust takes quite a bit of time to compile compared to Go. Okay, seems like we still have this error. yeah, it's probably still the version mismatch. So it's still under heavy development. And let's see if we can upload the binary that we've built without Docker. Oh, you know what? Let's actually go, since for some reason this command, maybe they've changed something with their image or with the binary. Let's see if they have the binary itself available, so we can just use that. Yeah, they actually don't provide a binary. Okay, that's a shame. Something in Cosmos land has changed, and yeah, their command no longer builds. Let's see if they've added something to developing. Yeah, seems like they're using a newer version of Rust Optimizer. That was the problem. Let's do that again. So they've updated their Rust Optimizer, and I should probably update my tutorial as well. So again, it's under heavy development, and breaking changes is something you should expect. So yeah, it will take a bit of time before it downloads a new image, because I have 0.8 installed, downloaded, but I don't have 0.9. So meanwhile, we can just look into the messages. So it's the difference between Cosmos and SDK development, aside from Rust and Go differences, obviously, is that you have much less code to worry about. Like that's the only code that's all the code you need, and the logic is contained in the contracts.rs and messages. With messages file, you can actually see how to use this application of yours. So init message describes the initial parameters, and you pass just a counter, an integer, and it has two actions. You can increment or you can reset. It's a very simple application. And yeah, eventually it will build our contract. The reason why it's building inside Docker, I've mentioned that it's optimizing the binary, the bytecode, I mean, but it also makes sure that you build it locally, so you don't have to trust anyone to build it for you in the same environment as any other contract. Question from chat: is there going to be an official documentation site? You mean for Starport or for Cosmos? For Cosmos, they do have documentation website. So it's a very interesting read. Highly recommend. For Starport, we're just starting from a README right now, but I don't think it will warrant a whole website dedicated just for Starport documentation, but we're working on the UI that will have help. So if you ever get stuck with something, then you'll be able to get help from the UI, similar to what we have right now, with just the welcome screen, but it will be something closer to like Vue DevTools if you're a front-end developer, just a set of tools that help you to work on your blockchain. Okay, seems like we've compiled, we've built our contract. And it's inside, it's a contract.wasm file. So if we look how, yeah, it's only 100 kilobytes, which is much better than we would have like 2 megabytes before. Now let's go through the process of actually using it. So first step is to actually to upload the code of your contract onto the chain. So we'll use the same, in our case, block CLI command tx wasm, and we've seen that it has a store subcommand, right? We use store subcommand. We pass the contract file, and we need to make sure that we tell which user signs the transaction. By default, we have user 1 and user 2 right now. And we pass enough gas so that it succeeds. Let's restart. Not full block. Counter. Unknown address. Interesting. Okay, let's check it out. Block CLI. Okay, let's check why we don't have this account anymore. Auth accounts. Interesting. Let's just delete. So the data files are contained inside your home directory, inside blog D directory in this case, and block CLI. We'll just remove them and restart in case we had some mix-up with keys, because it should provide us with 2 users. Okay, block CLI, keys list. Account does not exist. For some reason, it didn't provide us with coins at the init step. So we might have 2 accounts, but there are no coins there. That's very interesting. Okay, let's make sure that we don't have, yeah, we have a previous application still running, and we don't want that. We want a clean slate. So if something goes wrong, just kill everything. and restart. So we just had a zombie process that didn't get killed. Now if we go back and try this once again. Yeah, so now we have user 1, and it takes the bytecode of our contract and sends it to our application, to our blockchain. So after we do that, we should see this code being uploaded. So we're using blog CLI wasm and has list code command. We might have passed not enough gas for this to work. Let's try it again. Okay, for some reason we don't have, it didn't upload the contract. Okay, let's see that it's still 100 kilobytes, that's good. Again, probably something has changed in Cosmos land, because it should list our code. Blog out of gas wanted. Yeah, that's clearly not enough gas. Okay, let's again clear. Well, for some reason it doesn't want to upload the code. I guess they haven't released their first version yet, so it's to be expected something clearly has changed, because as we can see, they're using a different image for building this. Maybe they haven't updated the WASM library, but if we use the previous version, it would be much simpler. I mean, after you've uploaded the contract, you would instantiate it with an argument like 5, and your counter will start from 5, and then you will issue transactions that will actually increment the counter. So the point here is not to show off the clearly pre-release version of the software, but to make sure that people are aware that there are multiple ways of developing Cosmos applications, of course, there is like a very stable and production-ready Cosmos SDK, which is the preferred way of building applications right now. But the smart contract support is coming soon after the bugs are fixed, obviously. So both ways to build applications are valid, and sometimes you want to have this flexibility of uploading code after your blockchain has launched. And in this case, Cosmos can be the tool for you. So yeah, that's pretty much it. I guess now it's time to answer questions. Any questions? Adriana?
I have no questions on my end here for now. There was a comment from Nick. I don't know if you have seen it in the chat. He says, I think Starport could be improved greatly to the user and the developer if there was a Docker compose file linking a bunch of Docker files. Maybe he just wants your opinion on this.
Okay, yeah. That's a valid point, but then again, you would have a Docker as a dependency, so you wouldn't be able to use Starport without Docker. I can see this being useful, but I can't see this as a main way of distributing an application, because not everyone wants to have Docker installed. So, yeah. Again, one more question. Is Cosmos the same as Cosmos SDK just for Rust, or do they more work together? So yeah, they work together. So you can build the same application in Cosmos SDK and in Cosmos, but the approach is different in that. To me, like it's a very subjective matter, but to me it feels like Cosmos SDK is like a framework where you have everything set up for you. You have handlers, you have keepers, like the structure is very defined, and you have more files to work with, but there are more conventions. So it's like closer to Ruby on Rails, whereas Cosmos is more like Sinatra or Express.js, where you want this piece of functionality you want to handle certain messages, and you want to add it after the chain has launched. So the way I see it, and the way I see it is, you might want to build your application using Cosmos SDK, provide all the necessary features there, but you would extend your application later down the road with Cosmos, and you might allow your users to deploy their own contracts. So that wouldn't be really possible with just Cosmos SDK. So it's like a scripting language for your blockchain. For now, of course, I wouldn't be using Cosmos right now to build the whole application, just because it's in a state of active development. But I see that I expect it to become like a staple in Cosmos world, because it's just so useful to have this ability to deploy new functionality after the chain has launched without going through the upgrade process. And also one more point, that Cosmos team is actually planning on adding other languages. So you would be able to write your contract in assembly script, I think. So it's much later down the line, but it's something on their roadmap, I think, which should be much more familiar to JavaScript developers than Rust is.
Okay.
Before I just wanted to continue kind of one thing about Cosmos is that you can actually call Cosmos SDK. So it uses Cosmos SDK under the hood. So it is a complementary tool. That's all.
Okay, last questions before we wrap up. No more questions here. Dennis, any other questions on your end?
No, nothing in Zoom chat.
Okay, cool. Well, I think it's safe to say that we can conclude this workshop. Thank you so much, Dennis, for joining us and for presenting Starport to the Cosmos community. For everyone who has watched the workshop and thinks that they might want to see it again, we'll be posting the recording very shortly, tomorrow or the day after tomorrow. We also have a playlist on YouTube under Code With Us workshops, in case people who haven't joined our sessions before want to catch up with what we have done during those sessions. We also have Code With Us on the cosmos.network website. You can find it on cosmos.network/series/Code With Us. I have posted a link in the chat here above. So please make sure to follow up on the website also. We'll be posting all our future workshops there. We have another one coming up on the 4th of August. It's about experimenting with cross-chain NFTs, minting, and road trip TX with Cosmos IBC. It is presented by the team from FreeFlix Media and Cosmic Compass, and hope to see you in the workshop as well. In the meantime, if you have questions, if you need resources, if you think that you want to ask us something regarding this workshop or maybe something from the previous workshops, we have a dedicated channel on Discord under initiatives. It's called Code With Us. So please post your questions there and we'll make sure that we will answer them. And for everyone who wants to join for future workshops, make sure you sign up to the Code With Us newsletter. You'll be receiving all our future workshops, and whenever we post a new workshop, you'll receive a notification in your calendar. So make sure to follow that one, and hope to see everyone next time.